Afternoon. Thanks for joining the pre-lunchtime slot. I appreciate it. Blood sugar is probably down here. Hey. So I'm here today to talk about private edge AI managed by AWS. The reason is, well, I didn't see private AI on the agenda, so that was a good thing. Second thing is I didn't see any discussions around edge, so hopefully it's a different topic for you. And thirdly, I think it is going to be something that we can expect to see in the future or near term. So AI is pervasive, and I think we expect it to be in the cloud, and I think in the near to mid-term we're going to expect to see it at the edge of the cloud as well. But there's a lot of moving parts with edge computing, with private AI, and some of it will draw on experience that not everyone has, because we've all been so used to consuming services natively in the public cloud. So hopefully I can fill you in on some of the details today. Just a quick update on who I am, who I work for. I run a company called Storm Reply. We're part of the Reply Group. It's around 15,000 people around the globe. And the Storm Reply company is dedicated to AWS. So all of our engineers, architects, and governance folks are AWS focused. My background is tech for 25 years. Most of that has been in consulting and engineering. And since the launch of AWS, I've been building most client solutions in AWS. So that's a bit about us and me. So just to read the quote out, private edge AI solutions will be commonplace as expectations grow for real-time insights, reactions, and experiences of AI. The question is, can we shrink the compute enough, and can we manage the devices? The reason for the statement is that bringing AI technology closer to where we are, where the user is, where the consumer is already happening in different ways. So our mobile devices are promoting AI intelligence. But if you wanted to upscale that to a real workload privately, and the use cases are many, and I'll go through some of them, we will need a solution for that. And over time, AI tech will become small enough for it to live within field-based environments as opposed to always requiring the cloud. But Amazon still has a big part to play in that process. So the first bit, to break it down, so for the private element, you've got isolation and control. So by hosting Gen AI locally, you can isolate it within your network, limiting access to only those who have explicit permission. And this reduces the risk of unauthorized interaction and sensitive data. So isolating the workload is what deems this as a private AI solution. You could also, for your employees, for your customer, you could start to provide the right confidence and assurance that that data ownership and control is maintained. However, there's no point all of that being isolated and contained and not accessible. You need to be able to introduce the element of the edge of the cloud. So for the edge piece, this is all about managing the device centrally. It's about decentralizing the infrastructure, but still having control within AWS. So picture a device running locally, could be in a truck, could be on a desk, could be in a kiosk. The edge part of this is what allows you to leverage AWS IoT, device management, and also training the model as well. So imagine it as a central point in AWS, but you're pushing out to devices in the field that are running AI locally. And I think we're all familiar with the purpose of the AI piece. So we want to be able to automate common tasks. We want to bring inference quickly to people. This could be for, if we cast our minds to the future and the tech is small enough, you could have devices warn that are measuring sentiment analysis or behavior. There's a policing talk that just happened, and body-worn cameras are becoming commonplace, but imagine just the right amount of AI tech locally and just the right amount of connectivity to the cloud, then you start to run specific workloads on small but perfectly formed language models locally. So you could actually have a body cam that is doing inference locally. So this is the private piece, the edge piece, and the AI piece all coming together. So I won't drain all of these, but if we take the customer service automation piece, one of our customers came to us and said, we would like to have an AI kiosk and a digital human helping our guests choose products. So the first phase, we built it all based around what was available in Bedrock at the time. Now, the knowledge base, the actions, etc., those weren't the issue. And actually, it was a perfectly working solution from a Gen AI with language model attached. The digital human and AI kiosk piece is what made it drive it towards a private edge AI solution. So we took all of those components that run typically within the cloud, and we flipped the role of the cloud to become more of a device management and model update and training platform. So we took all of the tech that we are taking for granted available to us locally. So within this kiosk, it has a NVIDIA GPU. We're clustering across 2 boxes to keep it highly available. And we're using some great services. And I know this is private AI or all about AI, but just to plug AWS's IoT, Internet of Things service catalog, it's one of the best out there. So we're using all those IoT services to make sure the health of the device is correct, that it's patched, updated, secured. We're rotating keys. And we're also using it as a central place to deploy to. So back to the customer, they have limited internet access. And by limited, I mean it's very patchy, but a lot of guests. So you can probably imagine a travel and tourism scenario. I can't give all the details, but you can imagine no solid internet connection, an AI kiosk, digital human, driving someone through their selection of a product. And this now is going into production in about 3 months' time. So that forced us to work out how to pull all of this private edge AI tech together. And to give some examples of why, so in closed circuit television security, now there's a lot of solutions out there that can record, detect events, that can blur faces, etc. But we want to take that to the next level and start using a natural language to query. So when was door 2 last opened as a general query? So adding that layer of AI on top. And I think that by bringing security cameras, surveillance, traffic monitoring together and having specific edge AI capability, we can start to reduce that latency. We can start to get that immediate response of a question to data, which is considered mostly quite private. You don't want to be releasing CTT footage, real time. In the industrial space, we're working right now on taking a whole collection of line data, which is a common thing to do with industrial IoT, in Industry 4.0, another term to use, been commonplace for a while, capable. So now people have the ability to collect the data from their machines. Again, they want to be able to add an AI element. And in this case, it could be for predictive maintenance. So being able to bring together multiple points of, let's say, vibration, could be blade sharpness, could be number of items off the line. Being able to perform all that at the edge is what you can do here. And then, I won't go through them all, but the other one is autonomous vehicles. I mentioned shrinking the tech to a point where it becomes practical. There's one use case where you can, within a truck, you can read the data real time, and not just for tracking where the truck is, but actually start pulling together service information, mileage information, when it stopped, and all of that information, but as a purpose-built piece of AI at the edge, just running within the truck. And this is going to become more and more commonplace, in my opinion, I think, as it becomes more accessible. And then, of course, connectivity is improving. So taking these smart devices and allowing them to stay up to date via AWS is absolutely possible. If you like your hardware, this is a big part of it. So the hardware is a big part of making private edge AI work. There are things the size of our fingers that can perform this type of role. But, and it's a big but, it's a bit like the Apollo mission where they had a few kilobytes, or K even, to write the instructions to bring that shuttle back. You've got to be really thrifty with your code to make sure very small devices can run AI at the edge. That means your language models need to be really purpose-built. On the stand we have today, if you want to come say hello, I think we're running out of socks very quickly. So over there we have a model that's running 3 billion parameters locally on a very small bit of kit. And you've got to think about really trimming things down to work properly at the edge. You've got small board computers. Everyone's familiar with Raspberry Pi. I think over time we're going to start to see more and more advancements in stuff that actually does work as an AI role on things like Pis. The one here in particular is actually an industrial grade one, so it's built for that environment. You can drop it, kick it, freeze it, heat it up, still works. And there's now a whole heap of options in the personal computing space, which also extends to things like industrial personal computing. But back to personal computers, there's enough options now for you to deploy your own models locally. Some of you may even have teams working on it now. The point is, if you had 1,000 of these devices, how do you manage the consistency of your deployments, etc.? And that's where Amazon can come into this massively. And if you have enough money, you can go all the way to the Gen AI servers. And of course, what you don't want to do is introduce a whole piece of tech debt into your company of loads of hardware. So the whole point here is that, again, it's managed as an edge device, edge of cloud by AWS. Courtesy of Gartner, this is where people are with edge deployment right now. You can see that we have a big proportion of people that are not sure or not interested. And I think it's just a case of the right use case, the right tech, how accessible it is, and people feeling confident that they can actually keep it secure and keep it up to date. A good example of how you can experiment yourself, there are some options from NVIDIA. It's called a Jetson. Now, you might have heard of it before the silicon issues that ensued us around, I guess, around COVID time. You can now introduce your team to development kits where you can try out some of these ideas you have for using private AI. If you have personal information that you want to protect, if you want to perform inference locally and do analytics locally, then that's a good option for you. But being able to manage it centrally and connect it to AWS, training the model in the cloud. No presentation from me would be complete without some AWS icons. I didn't do an architecture diagram. I did start to, and I realized I'm in the business track, so I stopped myself. But I thought I would introduce some of these names if you haven't come across them. So AWS IoT device management, think of it as the thing that can keep a register of all your things out there, and a thing could be any of those pieces of hardware I mentioned before. anything from a full-blown server to a tiny chip on a connected product to make it smart. That's also managing the security of it. So if any of you are security folks, you can constantly run a CIS benchmark against all these devices. Could be one device, could be 100,000 devices. You can schedule jobs to perform remediation should it find a problem. So it's a great service, and I think it's underrated. Greengrass, think of that as a means to deploy applications, deploy databases to all these field devices. It's a long-standing service in the IoT suite, and one that if you're thinking of managing devices or going down the IoT route, will help you massively. And then if you've got devices collecting data, you'll need somewhere to process that data. And most devices are collecting some kind of asset information. And Sitewise is great because it's got two versions. It's got Sitewise Edge and it's got Sitewise in the cloud. This is great if you want to build a whole ecosystem of stuff talking to IoT data that's been collected locally by your private edge AI. It's free to query. There's not many services like that. It's a really structured way of forming your asset data. For the video option, things like surveillance cameras, you might have heard of Kinesis from a cloud point of view, but there's a video stream edge agent of that. So you can take all of your security cameras, point them at this stream agent, and it will work it out for you. And instead of sending days or hours and weeks of footage, you can send just the pertinent events that you are interested in happening. Could be for safety, so you might say, how many events happen where a broom fell over, or how many events happen where a door shut, and that's the kind of thing you can leverage. And the point here really is response time, reducing the latency, improving that experience of it. Systems Manager is fantastic for all of your fleet of infrastructure, be it in the cloud or on-premise. This could be a means to remotely connect. It can be a means to manage the system just as if you would have any IT infrastructure. And you probably are familiar with Amazon SageMaker. There's been some talks on it today. This is where we would envisage you training your model that you would update and eventually deploy out to these edge AI devices. There's a whole heap of other services. It's always growing. I wouldn't even want to quote how many services we're up to in AWS these days. But certainly there is something there for you. The logical steps are, if you take your use case, first point is, how am I going to integrate it? What do I need to integrate it with? So you might have a device that is on a vehicle. What am I integrating with? Then you've got to select your actual compute. If you refer back to the slide of the different hardware options, the smaller the compute, the more efficient you've got to make that application. Power is a big thing as well, so you might have to actually make it suit a certain amount of power. Training the model, you might already be training models, but it's a really key part of it to reduce the size of that language model. And then finally, getting the thing deployed. Not many steps involved really to pull it off. I think a lot of the areas that we could help with it as a partner of Amazon is take you through these steps. We could help you through the POC, pilot, MVP stage. Storm's particular objective is to make sure that we can teach clients to fish as opposed to be a single point of dependency, which may or may not be unique, but the idea is not to look for a sticky, unnecessary sticky connection. So to conclude a few things on private edge AI, we can enhance the data privacy, get that real-time decision making, which is sometimes underrated in terms of can I get inference from data quickly. An example of where it might be needed for emergencies. I didn't mention it before, but if I go back, if it works, if I go back to here, AI must react instantly for safety. So that real-time inference of data, you can't collect data, send it, process it, and come back with a response if something is less than a millisecond away from, crashing. So that's another use case for having that AI at the edge. Reduce latency. So I mentioned the use case of a customer that came to us, AI kiosk, digital human. The wait time for the digital human to make a response, it wasn't a bad response, it was just, it wasn't natural. It didn't feel like they were talking to another person. And that instant reaction of artificial intelligence is what they needed locally in an environment where there was very limited internet connection. So reduce latency. Edge computing can help with that with private AI. Scaling and flexing. I think I've mentioned at the end of most points about the AWS managing centrally thousands of devices and took you through some of the key services. And then future-proofing. I think if we work out a means and a way to adopt private edge AI for the right use case, you might be able to have an option for your product, for your customers, for your employees, even as a hybrid. So you could have the option of when that is required based on the type of data, or when it is required based on the environment that it's in. Some of our customers are FTSE customers, and they have sites where they just can't rely on power. And it's amazing to be in 2025 and hear a customer talk about brownouts in one of their most busy factories, as an example. So preparing for that is an option with this. Finally, we have a edge compute lab. This is currently in our London Victoria office. We're thinking of replicating it later in the year to other locations. The reason for this lab is, as you saw from all the different hardware options, there's a lot to test, there's a lot to work out, there's a lot to validate. Some of our customers in the industrial space will bring a subsection of their machines, and we show them how they can integrate and hook up. We have some customers in the connected product space, which is an example of the very small board compute space, where they can test the feasibility of measuring temperature, humidity, vibration of their connected product. So this lab is also great from a talent point of view. A number of our early career folks that join us have never touched a piece of hardware, and I think things like the Raspberry Pi started to bring people's connection back to how computers actually work. And because we've talked about private edge AI and all of the different nuances of hardware, I think it's important they have a place to learn what this space is and have a point of view. And that concludes my presentation. I tried to leave some time for questions, but also I'm conscious that you're all very hungry. But if you do have any questions, shout. Go on.
Yeah, do you see cost savings by pushing the compute to the edge? Because edge is free. This is all about.
Yeah, this is that old principle of CapEx versus OpEx, right? So yeah, I can't tell you that those hardware options come with a pay-per-use, 1 cent an hour cost model. Maybe one day that might happen, but yeah, there is a upfront investment required for anything that is edge-based from a compute point of view. You could argue edge computing is a better term for on-premise, but I believe the intention behind it was the edge of cloud, as opposed to on-premise with a bit of a connection to the cloud. So you're right, there is an upfront investment. There are some use cases where if you're constantly crunching a set of data locally and there's no point sending all of that to be crunched in the cloud. And IoT data is a great example where you don't need data for data's sake. You need the pertinent measurement that comes from that sensor. So, you know, how many times was it above 90 degrees? How many times was it below 90 degrees, as opposed to collecting everything just to make that decision? So yeah, there's an upfront cost with edge compute. And maybe the product teams of Amazon will start to think of edge options. I know they already have from a software point of view. I already talked about Kinesis Video Stream Edge. There's Greengrass, there's Sitewise at the edge, and there are other options as well. But yes, there's an upfront cost to the hardware. Say that again? In the automotive space, yeah. 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 You would need to buy a lot of small boxes that live under the dash. Yeah. Any other things? Any questions? No? Thank you so much for your time today, folks.